Using live data is a great way to make your prototype feel more realistic. In this tutorial, we'll build an App Store prototype that downloads live data from Apple's iTunes Search API using the network request patch. We'll use this data to update text and images and generate a loops list of applications. If you've already been through Introduction to Loops, this tutorial will show you how to bridge live data with loops. Download the starter tutorial files to follow along as we rebuild this prototype. The network request patch allows you to request live data in Origami from a variety of sources. Once you have live data in Origami, you can use it to fill content, generate views, and bind data to different layer properties. Alright, let's begin by selecting the patch editor and adding a network request patch. Do this by pressing Option Return, typing network request, and hitting Return. So to receive data from the network request patch, we need to add a URL input, an endpoint, and then tell the patch to request data from this URL. Copy the URL provided on the lesson website and paste it into the URL input. Now we want to request data every time the prototype starts, so we use the WhenPrototypeStarts patch. Add this patch and connect its output to the request input of the network request patch. Restart the prototype by clicking the refresh button on the viewer toolbar or pressing Command R. The network request patch will now load new data from the iTunes Search API. You can check this data by clicking on the value beside the results output. You'll see a popover appear displaying the results in a format called JSON. Now we'll explain this format in the lesson webpage, so feel free to pause the video here or continue as we briefly cover a couple of patches that will allow us to access the relevant data. If you scroll through the JSON, you'll see a lot of data. You're actually looking at the data for 19 applications. So to begin, we need to filter this data down so we can get access to the details for the first application. We'll do this by using two patches, the value for key patch and the value at index patch. We use a value at key patch to access data that is contained within two curly brackets, which we call an object. We use a value at index patch to access data that is contained within two squared brackets, which we call an array. Let's begin by using these two patches to return details for the first application. Insert a value for key patch onto the patch editor and connect the result output from the network request patch to the object input of this value for key patch. Then set the key input to results. Next, we'll add a value index patch and connect the value output of the value for key to the array input. We want the first results of this array, so we keep the index at 0. Now later on in the lesson, we're going to replace the value index patch with a loop over array patch. So for now, we're going to add and connect a splitter to the value output. Once this patch is added, right-click on the splitter and change its type to JSON. Now rename the patch to item. Alright, so now we have a few patches connected to the results output of the network request patch. Let's click on the inputs of each of these patches and see the JSON filter down to display the details of the first application. So now we have an object with the details for our first application. We're going to use these details to update some text layers. So in the layer list, open the apps group, then open the app details group, and inside you'll see a details group with text layers that we're about to update. Select the track name layer so we can see its layer details in the layer inspector. Here we want to update the track name layer with an application's name. So we're going to add a value for key patch and connect the item splitter to the object input. We're then going to enter track name as the key input. Next, we're going to bind the outputs of the track name layer by dragging the value outputs to the text input in the layer inspector. As we have 4 text layers to update, we're going to select the value for key patch, hold Option, and drag down to duplicate. We can do this 3 times, so we have a total of 4 value for key patches, all lined up nicely below each other. For the second value for key patch, we're going to enter primary genre name into its key input. Then track content rating into the third. And finally, formatted price into the fourth. As before, bind the value outputs of each patch by dragging and connecting to the text property of their corresponding layer. Once this is completed, you'll see the viewer update display details of our first application. Now let's update the blank icon layer with an application icon. Select the last value for key we created and Option drag to duplicate. Then enter artwork URL 100 into the key input. This value for key patch is going to return an image URL. Now, in order to download images in Noragami, we need to change the type of the network request patch. Add a new network request patch and right-click on the patch. Then select Type and select Image. You'll see the result output change to a checkerboard image. Now that we've added this network request patch, connect the output of the value for key patch into its URL input. Like with the previous network request patch, we need to tell the patch when to request. This time, we want this network request patch to only request when the first network request patch has finished loading. Now to do this, we're going to use a pulse patch to send a pulse when the first network request's loading output has turned off. This pulse patch will be used multiple times, so we'll utilize the wireless broadcaster and wireless receiver patches to keep the patch graph tidy. Alright, so find the first network request patch and insert a pulse patch nearby. Connect the loading output from this network request patch to the on-off input of the pulse patch. Then connect the turned off output to a new wireless broadcaster patch. And then rename the wireless broadcaster to loading done. Also, right-click on the patch and change its type to a pulse. Now go back to the network request patch with the image type and insert a wireless receiver patch nearby. You'll see the wireless receiver patch will be called loading done, and we want to connect that output to the request input of the network request patch. Give the prototype another restart. Now in the layer list, select the icon image layer. Then connect the results output of that network request patch to the image input in the layer inspector. When this is connected, you'll see the viewer update display a Facebook icon. Now we're going to update the 3 blank screenshot frames just below the app details. This time we'll access the screenshot URLs object. Now this object contains its own array, so we'll include a value index patch. Insert a value for key patch and connect the item output to the object input. And enter screenshots URLs into the key. Now add a value index patch and connect the value output to the array input. Add a network request patch and set the type to image. Connect the value index output to the URL inputs of the network request patch and connect a wireless receiver patch, the loading done, to the request input. In the layer list, expand the screenshot group. Select the screenshot 0 layer and drag the results output of the network request patch to the image input on the layer inspector. Restart the prototype, and you'll see the first screenshot appear in the viewer. To fill the 2 remaining screenshot layers, hold the Shift key and select the Value Index patch, the Network Request patch, and the Loading Done patch. Now hold the Option key and drag downwards to duplicate. Do this twice, so we have 3 copies. Change the index inputs on the second Value Index patch to 1, and change the index inputs on the third Value Index to 2. As before, select Screenshot 1 layer, and then bind the results outputs of the second Network Request patch to the image property. Now repeat this with Screenshot 2 layer and the third Network Request patch, dragging the results outputs into the image property. Then restart the prototype. We now have one group filled with live data for the first application in our JSON. Now we want to display all the remaining applications. So instead of duplicating patches, let's generate a loop using a loop over array patch. Go back to the first Network Request patch and find the Value Index patch that we used to select the first array. Now replace that Value Index patch with a loop over array patch. Reconnect the value output from the neighboring value for key patch to the array input. Then use the items output and reconnect to the item splitter. Now let's rename the item splitter to items. Next, we use this loop over array patch to lay out the results on screen. We use the index output to create and position each app detail group vertically. If you select the app details group on the layer list, you'll see it has a height value of 300. We therefore need each new app details group to have a Y position of 300 more than the previous app detailed group. To do this, we multiply the index of the loop over array by 300. Insert a multiplication patch and connect the index from the loop over array. Then set the second input to 300. Connect the output from the multiplication patch to the Y position input of the app details group. Give the prototype another restart, and as a result, each group will be positioned 300 points vertically below the previous group. We've now generated a list of results, but we can only see 2 applications on screen. So let's add a scroll view so we can scroll down the list to see all the applications. In the layer list, select the apps layer. Click the touch button and select Scroll Y from the menu. Let's make sure the app scroll group is large enough to show all of the applications. To do so, let's calculate the height of the group based off the height of each app details group, multiplied by how many items the loop over array patch has. To count the items in a loop over array, insert a loop count patch and connect the index output of the loop over array to the loop input of the loop count patch. Add a multiplication patch and connect the outputs from the loop count to the first input. For the second input, we'll use the height from the app details group, the same 300 that we used earlier. Connect the output from the multiplication patch to the height input of the apps group. And that's it. The prototype should now be filled with live data from the Network Request patch, laying out each result on the screen with a dynamic scroll view that displays all of the applications from our original Network Request patch.